Hi, I'm Kent Mertz, Product Manager at AAF International, and today we're going to look at three common industry terms: pressure drop, pressure differential, and resistance.
While that's several terms, in most industry conversations, these terms are used interchangeably. Essentially, they describe how much the filter resists airflow and how much pressure builds up because of that resistance. In the US, this is typically measured in inches of water gauge, which we discussed in an earlier video. This is a data sheet for a MERV pleated filter. You can see at an airflow speed of 300 feet per minute, the filter has an initial resistance of 0.23 inches of water gauge. For comparison, this is a data sheet for a MERV 13 pleated filter. At the same airflow speed of 300 feet per minute, it has a higher resistance of 0.27 inches of water gauge. The MERV 13 filter has a higher capture efficiency of the smaller particles, but restricts the airflow more and increases pressure. Why is this important? Higher pressure drop means the air handling unit must work harder and consume more energy to move air through the system. So, how do you reduce energy costs if you need a high MERV rating? Take a look at these two data tables. Both are for a MERV 13 filter, but look closely. They have different pressure drops at the same airflow speed. Filter 1 shows an initial resistance of 0.27 inches of water gauge at 300 feet per minute. Filter 2 is 0.31 inches of water gauge at the same airflow rate. That means air moves more easily through filter 1. Because the airflow encounters less resistance in filter 1, the differential pressure stays lower and the air handling unit uses less energy. Over the life of the filter, as the filter loads with dust, its resistance or pressure drop increases as the dust cake continues to build on the filter media. The filter with higher resistance will always make the system work harder and use more energy. So, what makes one filter lower in pressure drop than another? There are two critical factors. One, better media traps small particles while providing more microscopic pores for air to pass through. And two, a filter with more media surface area gives air more low resistance pathways to flow through. Since air follows the path of least resistance, this reduces pressure buildup and overall energy use. To sum up, pressure drop directly affects air handling unit energy usage. Lower resistance means a lower pressure drop and lead to lower operating costs. Reach out to us if you have any questions. At AAF, we are bringing clean air to life.